Hello everyone! Welcome to Teacher Hanji's channel. For today's tutorial, our lesson is about basic proportionality theorem and the converse of the proportionality theorem. So first, let us define what is a basic proportionality theorem. So the basic proportionality theorem or the triangle proportionality theorem states that if a line is parallel to one side of a triangle and intersects the other two sides in distinct points, then it divides the sides proportionally. So let us draw here a triangle BUG, in which from the basic proportionality theorem, it means that there is a line that will intersect the other two sides of our triangle. So let us draw line AB here, in which AB intersects side UB and side UG. Also part of this proportionality theorem, the line should be parallel to one side of our triangle. So it means AB is parallel to BG here. Then it divides the sides proportionally. So it means that AU over AB is equal to UB over BG. So this is the illustration of basic proportionality theorem. So let us have another triangle. Given here is triangle CAT. So again, let us draw a line that intersect the two sides of our triangle. So let us draw line CD, in which C divides the side AT and D divides the side CD. From our proportionality theorem, that line should be parallel to one side of our triangle. So it means that CD is parallel to AC. If this is the case, then it divides the side proportionally. So it means that AC over CT is equal to CD over DT. So that is how we deal with basic proportionality theorem. Let us now move on with converse of the proportionality theorem. So the converse of the proportionality theorem states that if a line divides two sides of a triangle proportionally, then the line is parallel to the third side. So let us draw again a triangle. So we have here triangle SIT, in which we will draw a line that will divide the two sides of the triangle proportionally. So let us draw line EF. From here, we can state that IE over ES is equal to IF over FT. So if these two sides are proportional, then we can say that EF is parallel to ST. So that is how we deal with the converse of the proportionality theorem. So let us have the following examples. Number 1. In triangle ABC, DE is parallel to BC. Given that DB is equal to 3, AE is equal to 2, and EC is equal to 6, let us find the length of AD. Since it says here that DE is parallel to BC, so using the proportionality theorem, we can say that AE over EC is equal to AD over DB. So let us substitute the values of the length of AE, EC, and DB here. Therefore, we will have 2 over 6 is equal to AD over 3. For us to know the length of AD, let us multiply the means and the extremes of our proportion, or simply do a cross multiplication. So let us multiply 6 times AD and 3 times 2. Therefore, we will have 6AD is equal to 6. Let us divide both sides by 6 to isolate AD here. Therefore, the length of AD is equal to 1. And that is the answer. Let us have number 2. Which of the given triangle shows that VW is parallel to YZ? Remember that in converse of proportionality theorem, the line should divide the sides of our triangle proportionally. So for us to know whether VW is parallel to YZ, let us check whether the two sides are proportional. For number 1, we can say that XW over WZ is equal to XV over VY. So let us substitute the values of each length. Therefore, we have 12 over 30 is equal to 10 over 25. So again, to check whether this one is proportional, let us multiply the means and the extremes or simply do the cross multiplication. Therefore, we have 30 times 10 and 12 times 25. We will obtain 300 is equal to 300. Since this one is equal, then we can say that VW is parallel to YZ. Therefore, the first figure is true. Let us have the second one. Let's check whether WV is parallel to XZ. Therefore, we will have this proportion YV over VX is equal to YW over WZ. Let us substitute the values of each length. Therefore, we have 2 over 3 is equal to 6 over 8. So again, let us multiply the means and the extremes or simply do the cross multiplication. Therefore, 3 times 6 and 2 times 8 is equal to 18 equal to 16, which is not equal. Therefore, we can say that it does not shows that VW is parallel to YZ. Therefore, the second figure is false. Let's move on with example number 3. Given that DE is parallel to DC, find the value of X. Then, from basic proportionality theorem, we can state that AD over VD is equal to AE over EC, in which AD is equal to X plus 2, DV is equal to 6, AE is equal to X plus 1, and EC is equal to 5. Let us substitute those values here. Therefore, we have X plus 2 over 6 is equal to X plus 1 over 5. So again, let us multiply the means, which is 6 times X plus 1 and 5 times X plus 2 for the extremes, or simply cross multiply. Therefore, we have 6 times X plus 1 is equal to 5 times X plus 2. By distributive property, we will obtain 6x plus 6 is equal to 5x plus 10. Using addition property of equality, by adding negative 5x to both sides and negative 6 to both sides, or simply transpose 5x to the left side of our equation and 6 to the right side of our equation, then we will have 6x minus 5x is equal to 10 minus 6. Evaluating this one, we will obtain x is equal to 4. Therefore, the value of x is equal to 4. Let us have example number 4. In triangle RST, given that xy is parallel to TS, find ry. Given that rx is equal to 7, xt is equal to 3, ry is equal to x plus 24, and ys is equal to 3x. For us to find the length of ry, we need to find first the value of x here to be substituted to the given values of ry. So let's begin. Since it says here that xy is parallel to ts, then by applying the basic proportionality theorem, we can state that rx over xt is equal to ry over ys. Let us now substitute the values of rx, xt, ry, and ys. Therefore, we will have 7 over 3 is equal to x plus 24 over 3x. So again, let us multiply the means and the extremes or simply do a cross multiplication. Therefore, we will have 3 times x plus 24, this one, is equal to 7 times 3x, this one. By distributive property, we will obtain 3x plus 72 is equal to 21x. So again, let us use addition property of equality or simply transpose 21x to the left side of our equation and 72 to the right side of our equation, so we can isolate the terms with variables and the constant. Therefore, we will have 3x minus 21x is equal to negative 72. Next, let us evaluate this one. We will obtain negative 18x is equal to negative 70. To isolate x here, let us divide both sides by negative 18. Therefore, the value of x is equal to 4. So again, our task is to find the length of ry. So since ry here is equal to x plus 24, and the value of x is equal to 4, let us simply substitute it here. Therefore, ry is equal to 4 plus 24, in which 4 plus 24 is equal to 28, and that will be the length of ry. Let us have our last example, number 5. What will be the value of x to show that by is parallel to SA? So again, we will be using the converse of proportionality theorem, which states that this line should divide the two sides of our triangle proportionally. It means that in order to find the value of x, then we will have this proportion SB over BT is equal to AY over YT, in which SB is equal to x plus 1, BT is equal to 2x, AY is equal to x minus 1, and YT is equal to x. Let us substitute those values to our terms here. Therefore, we have x plus 1 over 2x is equal to x minus 1 over x. Let's do the cross multiplication. Therefore, we will have 2x times x minus 1 here, x plus 1 times x, or x times x plus 1 here. Let us do the distributive property. Therefore, we will have 2x squared minus 2x is equal to x squared plus x. If you notice here, we obtain a degree of polynomials which is equal to 2. So it means we will create here a quadratic equation in which x squared will move to the left side of our equation, as well as x will move to the left side of our equation. Therefore, we will have 2x squared minus x squared minus 2x minus x is equal to 0. Let us combine the like terms. We will have x squared minus 3x is equal to 0. Take note that to find the value of x in a quadratic equation, we need to get the factors of this one, in which x squared minus 3x is equal to 0 is also equal to x times x minus 3 is equal to 0, in which x for the first one is equal to 0, and from x minus 3, x is equal to positive 3. So we have here two values of x. Let us substitute these values to our proportion SB over BT is equal to AY over YT to check which value shows that BY is parallel to SA. So let us check first if x is equal to 0. Substitute it from x plus 1 over 2x is equal to x minus 1 over x. So again, I use these proportions to illustrate this one. Substituting 0 to our x, therefore we will have 0 plus 1 over 2 times 0 is equal to 0 minus 1 over 0, which is equal to 1 over 0 is equal to negative 1 over 0. So from here, we already have undefined terms in which there is no side equal to 0. Let us check whether x be equal to 3. Let us substitute 3 to our proportion x plus 1 over 2x is equal to x minus 1 over x. Therefore, we will have 3 plus 1 over 2 times 3 is equal to 3 minus 1 over 3, which is equal to 4 over 6 is equal to 2/3. Using a cross multiplication, let us multiply 6 times 2 and 3 times 4. Therefore, we will obtain 12 is equal to 12. So from here, we can say that the sides was divided proportionally. Therefore, we can now say that the value of x is equal to 3 to show that by is parallel to SA. So that is how we will use the basic proportionality theorem and the converse of the proportionality theorem. So that's it for our tutorial. Thank you for watching. See you again in my next video. Bye!